Hi, everybody. Today's lesson is for Monday, April 20th. I hope you had a great weekend. Kind of as a full disclosure, I'm recording this again on Tuesday. This is the same day I just recorded lesson 36. I had a bit of a technical difficulty at the very end of the last lesson. I thought I was showing a PowerPoint and it wasn't, so I just kind of cut that out. But I did think I could show it in this lesson. It's just a really quick example of kind of the scope that I'm expecting for project 2. So I'll show you sort of an in progress example of project 2 that I've been working on. Let's go ahead and jump to the notes. Great. So as a reminder, project 1 is due today at 11:59 Eastern time, PM. So please go ahead and submit that either to Blackboard or Google Classroom, or send me an email, or feel free to just send me an email as a backup anyways. The schedule, remaining schedule, we've got today's class, where again, the goal is to work on project 2. I'll show you a quick example, and again, submit project 1. Wednesday, again, the plan, I'll just post a very short video with kind of these, reminder dates, but work on project 2. I'll also post on Google Classroom and Blackboard a practice final exam and the solution. So that should be a good way to sort of start preparing for the final exam. And hopefully by, this Monday, actually Monday or Wednesday, we'll have some more clear guidance sort of from the leadership. Again, barring, no information, the plan is to sort of have a final exam that's on a similar but maybe slightly shorter than the exam 2, the 12-week exam. Again, focusing on content that's new, so environmental loading, but a little bit comprehensive, so also considering some API checks and direct stiffness method, and maybe some STAD, very basic questions, sort of just asking about the process. Anyways, Friday, I'll post a review video, sort of just touching on the big concepts to review for the final exam. Keep working on project 2. That should be a pretty short video as well, maybe about 20-25 minutes. And then Monday is our official last day of classes. So we're getting there, guys. Hang in there. That day we'll do some course wrap up, feedback. And then also I'll post a PowerPoint video that you can watch, kind of just a little bit of a fun PowerPoint to end the year. And then again, let's kind of finalize about a question and answer session. We can either do sort of a live class on Monday. I can do that at another convenient time on one of the reading days. So I'll probably send out a Google form, this weekend as we get closer to sort of next Monday. And then finally, the final exam itself is going to be on April 30th. The project 2 is also due that day. If you're finished with it sooner and want to submit it sooner, that's totally fine. And that's it for EN 441. So I'd like to thank you guys. I'll probably thank you guys a lot the next 5 classes, but it's been a crazy semester, and thank you for your flexibility and your work and all of your positivity as we transition to online. It's been really great, and I'm excited to see you guys all back on campus in the fall. At any rate, last time we did some in-class, in quotes, work on project 1. I introduced the project 2 assignment. Today, I'll just show you a really quick example of project 2, and then please use, again, the rest of this time to either finalize and submit project 1, or go ahead and get cracking on project 2 to knock that out the door. So I'm gonna go ahead and share my screen. And here is just an example that I started working on for project 2. I decided to do the Block Island Wind Farm. If you're doing that already, if you've selected that, pretty cool. No need to have yours look exactly like mine. Again, there's a lot of engineering judgment here that lets you kind of take some creativity in how you want to interpret these structures as considering the concepts that we've talked about in EN 441. So again, just reminders kind of for deliverables. Slide 1, all I need is the name of the structure, the name of the structure or the system that you're analyzing, your name, and then a picture. Slide 2, we're looking at location and environmental information. For the design wind speed, I just consulted our figure 3.3 from the class notes, the figure of the United States that shows kind of offshore wind speeds. I multiplied that times a gust factor of 1.2 and an offshore amplification factor of 1.1 to get my expected wind speed. And then the design wave height, I got from the Army Corps of Engineers. They have some really good information about return periods for wave heights. Again, feel free to consult NDVC, NOAA, Army Corps, just as long as you cite your source. And if you're looking sort of for information from the past 5 days, that's totally fine. And again, you have some flexibility to use engineering judgment about how you actually scale up those design wind speeds and wave heights. So feel free to, as long as you clearly state your method, you have a lot of flexibility here to set these design environmental conditions. Next comes the environmental loading. Again, this is going to be consistent for everybody. We have a pile with a 5-foot diameter and 50 feet water depth, extending 15 feet above the surface, so 65 feet in total length. Based on that, please calculate the maximum drag force, the maximum inertial force. The maximum force, you can use your spreadsheet from the project one, should be very helpful for that. You're going to have to sort of re-optimize it. And then these are based on the environmental conditions that I had. Also, you'll be calculating the wave force, the wind force. And then just, you know, go ahead and show sample calculations. I still need to show the sample calculations for this. So please, you know, make sure you include those either handwritten, you know, in a picture of that along with your submission. Next is the structural analysis. I had 2 pile cross sections. I assumed that sort of you could take this yellow structure, which has 4 of these piles, and I'm just considering 2. And again, simplifying things by assuming that they connect at the center. Not totally true. I'm ignoring some of the bracing, you know, in the piles too. But again, it's really your call with how you want to simplify the structure for structural analysis. And again, here you can just talk through what the piles would look like. So again, I assume 2 because we're just looking at a 2D structure. I found some information about the dimensions of the piles, and then talking through how you would set up this in STAAD or using the direct stiffness method. So how many individual stiffness matrices do we have? We're using a plane structure or a truss. You know, how big the stiffness matrices would be, and then the system stiffness matrix. Then finally, some other considerations. So these are just some fun facts I found. I guess it has a capacity of 30 megawatts, which is a lot, and is, you know, pretty cool in terms of like green engineering. Also, the full structures are really tall, so 600 feet is really, really high, and so I'm really interested to see sort of how they connect those. And you know, I think they had to use some pretty strong steel and some pretty you know, strong materials and thick large pile concrete, etc. You know, to satisfy some of those API criteria. And then just kind of, you know, thinking about how this compares to structures from EN 441. So the wind turbine is quite similar, but there are definitely differences and definitely considerations that we don't talk about in class. So how you transmit power, how you include all of these other components of the wind farm, like the turbine, how you protect it from corrosion, winter storm events, you know, other things that maybe go beyond just the scope of EN 441. And then finally, just a list of references. So as you can see, this is, you know, kind of a very broad overview, but I really, again, want this project just to be a way for you guys to investigate a new type of structure and, you know, have some experience thinking about how, you know, some of these structures can be simplified for structural analysis and how the complexities, you know, require a lot of work. And that's why these projects, you know, in the real world take years and years to design and build. You know, not just 1 week like we had for project one in this class. So again, I hope you guys are doing great. I hope the end of the semester, you know, winds down pretty well. Please don't hesitate to drop by online office hours or let me know if you have any questions or if you need anything. But thanks so much again, and looking forward to talking soon. I'll go ahead and